Q13, quite a challenging question for some of Year 12 students. This one linking the classical physics to modern physics. The examiner here is asking about how observations from photoelectric effect demonstrate the particle nature of light. So I have like some secret keywords to answer the question. So firstly, I need to link the energy of photon to the frequency, and the second point to make sure we have kind of photon and electrons as keywords. Remember that we have kind of the energy, as I told you, equals HF. Remember that we have electron, we have kind of frequency in terms of energy or kinetic energy. So remember, the kinetic energy depends on frequency as well, and I, which is intensity, depends on number. If you memorize these important keywords, you're able to answer the question. So we try to convince the examiner that we are familiar with modern physics. So firstly, we have photon, and photon in physics we has energy, and the energy of the photon, which is EPH, is related to the frequency, and according to the formula, EPH equals HF. Remember, so I get point one. Remember that any incident photon, so one photon or each photon in this question is doing what? Is interacting. So interacts with one electron. So there's only one interaction between one photon and one electron. It means that the energy is delivered to the electron simultaneously. So I would say, as a result, one electron or one photo electron is released. What the effective keyword? Simultaneously. If you're not happy with the word simultaneously, you can say instantaneously. It's an instantaneous release of photoelectrons due to the interaction with the photon. So I get 3 points here. To get the point number 4, indicative point 4, which is um, there is one formula is very famous in photoelectric effect, which is E of the photon equals to phi plus kinetic energy, which is maximum kinetic energy. Remember this formula. So E photon equals phi, which is HF threshold, plus kinetic energy. So if you want to release one photoelectron, your energy of photon must be equal to the minimum energy required for this release, which is phi. Phi here, which is the work function. So the energy of photon is equal to the minimum required energy to release one photoelectron, which is equal to the work function, or the frequency of the photon must be same as the frequency, which is threshold the frequency. This is the frequency that, which is, if you multiply times h, you get the work function, which is also the minimum frequency is required to release one photoelectron. So now I get 4 marks. If the energy of photon more than phi, so the excessive energy is going to be given in a form of kinetic energy. So as the frequency of the incident photon is more than the work function, so the kinetic energy of released photoelectrons or electrons increases as well. So the intensity of the incident photons affect what? affect the number of released photo electrons. So as the intensity of the incident photon increases, it means the number of the photo electrons increases. So finally I get 6 marks. So please do not forget, share and like and subscribe to our channel, and see you, and all the best for tomorrow's exam.